It's a pleasure to welcome you all to this solar energy training. We are still letting people in. I'm very happy to see that so many managed to join. My name is Marianne. I'm the Secretary General of Engineers Without Borders Norway. And just so you are all aware, this training will be recorded and we will publish it afterwards. And I will also ask everyone to keep yourselves on mute unless you are speaking to everyone. Take next slide. So this training is part of the collaboration that Engineers Without Borders Norway have with GETSCO. In order to address the emergency needs for electricity, the most efficient solution, obviously, is to provide smaller and modular distributed solar energy systems. And this is now phase 1, and we are assisting with the technical documentation for how to design and install solar mini grids. And then also in parallel, this training program that has been designed to address the skills to safely design, install, and operate immediate recovery solutions. There is a total of 5 modules that you see on the right-hand side. All training is conducted by renewable energy experts, and I'm very happy to have here with me today Naim Ode, Stanislav Merlet, and Michelle Batik, who will be going through this first training.
Caroline will join.
Yes. So this is the program for today. We have a total of 1.5 hours. We really encourage active participation. After each of these components, there is time for questions, but also as we go along, please just raise your hands or unmute your mics and ask. And just to let you know, if you are uncomfortable in English, please speak in Arabic. Naim is a fluent Arabic speaker, and it's also possible to write in the chat. Okay, so with that brief intro, then I'm happy to give the word to Michelle, who will start on solar fundamentals.
Thank you. Thanks, Mariana. Good morning, everyone. My name is Michelle. I'm a mechanical engineer, and I've done my master's in solar energy almost 15 years ago. Yeah, 15 years ago. And since then, I've been working with solar. Since then, I've been working in solar in Dubai, in the Middle East, and then back to Scandinavia in Norway. And yeah, I will be taking you today through the fundamental part and the solar panels component. Just one question. Is it okay, Mariana, if I take it in Arabic, right? I think it's okay. We discussed that. I forgot.
We kind of said it's in English.
Oh, yeah.
There are some, maybe some non-Arabic speakers as well, but I'm not sure. Are there any non-Arabic speakers here? Because if there isn't, then probably Arabic is.
But we can just highlight it in general. Let me just quickly. Guys, السلام عليكم، صباح الخير لكم الجميع، يعطيكم العافية. التريننج هذا مخصص لكم الجميع، خاص بجدكم والبارتنرز او الشركاء المحليين لجدكم. بما انه مخصص لكم، ما تترددوا اذا اي حدا عنده اي سؤال اي استفسار انه تساله. اذا حدا عنده مشكله بموضوع اللغه او يسال بالانجليزي، ممكن بكل سهوله يسال سؤاله بالعربي، ونتعاون مع الفريق انه نترجمه ونعطيه الجواب الصحيح باي آلية هو ممكن يفهمها. فما تخجلوا بالموضوع السؤال، وحتى خلال الشرح اي نقطه بتحسوا انه صعب او ما يعني كان صعب انها توصل بلغة المدرب ممكن بس إنه يعني raise your hand واحكي إنه أنا ما فهمت هاي النقطة، ممكن نعيدها بالعربي تتفسر، لأنه الغرض من البرنامج إنه الجميع يأخذ نفس المستوى من المعلومات، فهو مخصص إلكم، ودورنا الجميع إنه نقدم المعلومات الموجودة. عندنا فريق قوي بخبرات قوية جدا من مناطق مختلفة من العالم اللي راح يكون معاكم اليوم والأيام القادمة، فهي فرصة مهمة جدا إنه الكل يستفيد والكل يتعلم. ميشيل بيحكي عربي وبيحكي إنجليش، إذا بتفضلوا تكون الجزء تبعه يحكيه بالعربي فهو قراركم، يعني هو عشان البرنامج انتوا الاونرز للبرنامج مش احنا، فاذا بتفضلوا انه يقدم جزء تبعه بالعربي احكوا لنا، او ممكن يكمل بالانجليش زي باقي السكشنز في المستقبل. فاحكوا لنا هيك على السريع مشان نكسب الوقت، بس شو بتفضلوا؟
I suggest maybe we start Naim in English. We can
Okay.
start in English, and let's see how it goes. If the guys feel we need to shift to Arabic, we can do that. Because also there are many terminology I will not be able to translate. I will just use in English. So sorry for the confusion with my question, Mariana. And yeah, we'll go ahead. Naim, I will share the screen if that's okay.
Let me stop sharing from my side.
Yeah. Just you guys let me know if it's working well. Do you see the presenter screen or the normal screen, the full one?
The presenter one, Michel.
Okay.
Slide and everything.
Okay, then I should change it. Okay, so today we will start talking about solar fundamentals, and then we'll start talking a bit more about the components. So a general discussion about solar, and then the components of the system. Our session today is just the beginning. So if you feel that this information, you know many of it already, don't worry, we will go deeper and we will dive deeper into this topics in the future sessions that we're having as part of this program. So today I will start by talking a bit about the solar fundamentals, and it's always good to go back to history. The photovoltaic effect was discovered 1839 by Becquerel. It's an old thing, but again, if you discover something scientifically, it doesn't mean that you can use it in everyday life. So it took us almost 100 years until Bell Labs created the first practical solar cell modules, solar cells, which means they convert solar radiation into electricity. And then after that, we started using them, first of all, in space, and then started more and more when they became cheaper, better efficiency to enter into residential and commercial markets. And now we see them every day around the world. It's good to mention, it's not written here, that Einstein got his Nobel Prize in physics because he was able to explain the Becquerel photovoltaic effect. At that time, they just could not give him, no, they wanted to give him a Nobel Prize, but they probably could not understand well or confirm the relativity theory, so they gave it to him because of photovoltaic effect. Now, what is the photovoltaic effect? Of course, if we want to go into the structure of the cell, of the atoms, and look into atomic, it can be a bit complicated, but it's very good to explain it in simple terms, as the last line here shows. You have light that's hitting certain components, certain material, and this light excite electrons. And electrons, when they are connected outside through an external circuit, they make a current. And this is basically what happens here. So it's a very straightforward conversion of photons that come with the solar radiation into electrons that form a current. Now let's speak a bit about the cells. In the old days, we used to talk a lot about polycrystalline and monocrystalline cells, and these two, you can see them here. Basically, around 90% or maybe 99% of the solar modules in the world are made using silicon, crystalline silicon. In the old days, as I said, they used to be either polycrystalline or monocrystalline. Do you see my pointer on the screen?
Yeah, we see it.
Yes.
But okay, so I have the pointer now on the polycrystalline. So these cells, they used to be made, poly means multiple and crystalline means crystal. So a number of crystals, not only one crystal. So you see here, there are these small lines that are showing you where are the different crystals. While on the right side, this is called monocrystalline. So the whole cell is made only of one crystal. Of course, the solar industry is one of the industries that really changed a lot in the last decade. So in the previous days, when I started working, we used to have cells of the size 6 inches. That's 156 by 156 millimeters. Nowadays, of course, they are different sizes. They are a bit bigger, up to 210 by 210 millimeter. Of course, all of these are modifications to improve the efficiency of the solar cells and later on the solar modules. So if you want to talk a bit more in numbers, around 98% of the produced solar cells are made with monocrystalline nowadays. The poly is not so common anymore. In the old days, it used to be cheaper to buy polycrystalline. Nowadays, the price difference really does not justify the need for polycrystalline. Monocrystalline is made really in a very, very good prices and higher efficiency than the polycrystalline. So 2% of the modules are still made with thin film. I don't think we'll talk about it in our presentation today. Maybe another workshop, we'll talk a bit about thin film. And in the old days, you could tell, apart from the color, so the polycrystalline used to be more bluish, while the monocrystalline was more black. You could tell also from the shape. So you see with the monocrystalline, they used to chamfer them, the square on the edges. So it used to have this distinct shape. As I said, nowadays we're working with bigger sizes of cells, and most of the time they are half cut. So you don't see the full size of the cell in the module. Now the modules, of course, the cells, of course, is not something that we work with. We as engineers, we start working with the modules, not the cells. And the modules are made out of cells. So if we see here how they look like, how a solar system looks like, for example, we have a cell and then a number of cells that are connected in series. They form what we call a module, and then a number of modules that are connected into in series or in parallel or both. They form what we call array. So first we get the silicon wafers from the silicon ingots, and then we convert them into cell by adding the front and back contacts and adding the anti-reflection coating. And then we combine all of these cells to connect them in series to form the modules. Now, if we want to talk a bit more about the modules, modules are really a very interesting components that are made with another subset of components. So, for example, here, if we look, it looks like a cross section here. We will see that we have cells that are sandwiched usually between glass in the front and plastic from the back, or glass also in the back. And we put what we call encapsulation material. In this case here, it's the EVA, encapsulation material, which is also surrounding the cells from the back and the front. And then, of course, we have to seal it from the edge and put the frame if it's a framed module. Now, all of these components, they are for protecting the cells. The cells are very sensitive for all types of environmental conditions, all types of mechanical impacts. So that's why we put the encapsulation material, which is transparent, of course, to allow all the light to go through, and the glass to protect them from humidity, to protect them from hail, mechanical damages, and all of this. Of course, there is a limit. They cannot protect it from everything, but that's why we have the glass and encapsulation material. Of course, we cannot talk about solar energy without talking about sun and the solar radiation. And here we see the parts, the components that make the full solar radiation. So when we're speaking about direct radiation, we will be talking about the portion of solar energy that arrives directly to the sun. I'm not inviting you to look into the sun, but if you look at the sun, the radiation that's hitting your eyes, that's called direct radiation. While if you look at the sky in any other part, not to the sun, this is what we call diffused radiation. So there is a portion of the solar radiation when it enters the Earth's atmosphere, it gets diffused, and that's why we see all this blue sky. This is diffused light. So if you look at that side, you get also light. It's not only the light that's coming from the sun, but there is also this part which is called diffused radiation. And the third component of the solar radiation is what we call the reflected radiation. It can be reflected from anything. It can be reflected maybe from the building next to you. It can be reflected from the ground. All of these is called reflected radiation. And the sum of these three types of three components of radiation is what we call global radiation, which is all types of radiation together. So to sum it up, we have direct radiation, direct fraction of the radiation, which is coming from the sun. We have diffused, which is coming from the sky, apart from the sun. And we have reflected, which is reflected on all other surfaces surrounding us. The component of it that is reflected from the ground is called usually albedo. And we will talk about it later especially when we are working with bifacial system.
تمام، ونص ساعة أو ساعة أكلم مهند بكون في المحل. بس يا عم هم معترضين، يقول لي اليوم الشركة ما دفعتش المصاري.
Okay. Now let's talk a bit more about some terminology when it comes to solar radiation, and many of these will be very helpful again when we're speaking about the sizing and simulations. So it's very important to differentiate between solar irradiance and solar radiation. Solar irradiance has the unit of watts per square meter. Solar radiation, it's watt-hours per square meter. This means the solar irradiance is power, capacity, while the solar radiation is energy. That's why if we take the solar power and make it through time, we convert it into energy. That's what we need to keep in mind. So solar irradiance, we're speaking about watts, we're speaking about power. When someone says solar radiation, it means we're talking about this power through durations, through a duration, either 1 hour, 1 day, 1 year. So this is when we're talking about solar radiation. The insolation is just another term for the solar radiation, but usually it's used when we are talking about 1 day. So if someone tells you that there is 5 kilowatt hours per square meter insolation, you know that at that specific site, we get per day around 5 kilowatt hours. Now, if we multiply this figure by 365, we get that you cannot talk about it anymore as solar insolation, but you have to refer to it as solar radiation. And then if we take this solar insolation, and instead, if you look here, you see that the radiation changes during the day. It starts low in the morning, and then it reaches the peak during the solar noon, and then it goes down during the afternoon until the evening, until the sunset. So the value of this radiation changes during the day. But if we're speaking about sun peak hours or peak sun hours, what we do, basically, we take this solar insolation, and instead of saying, let's say, we have a radiation that is changing from 80 watt hours in the morning until maybe 800 watt hours during the middle of the day, we say we are having 5 hours. Each hour we have 1000 watts. So in this case, we replace the unit. Instead of using 5 kilowatt hours per square meter, we say 5 hours of peak sun hours, which means 5 hours of a radiation equal to 1 kilowatt hours per square meter. It's important to understand that, because later on we will relate this sun hours and we will be using it to be able to estimate how much generation we will have out of solar during a certain period of time. We just need to figure out how many peak hours, and then we multiply it by the nominal capacity of the system. Again, I think we will talk about this later, but it's very good to try to remember this. If we're speaking about peak sun hours, it means how many hours we have a radiation of 1 kilowatt hours per square meter. And even if we have never achieved 1000 watts radiation during the day, we can say 5 kilowatt hours per meter square per day, it's equal to 5 hours of 1 kilowatt hours per square meter. It might sound confusing, but if you have a pen and a paper in front of you, just write it down and see how easy it is. 5 kilowatt hours equals 5 hours multiplied by 1 kilowatt hour per square meter, kilowatt per square meter. Okay, any questions so far? Okay, sorry, I don't know. I got disconnected. I'm back again now. So, any questions?
It's clear.
And then I will ask some questions. Does anyone remember the difference between solar radiation and solar irradiance? One of them is power and one is energy. Which one is power?
Solar radiation is power.
No, solar radiation is energy. Solar irradiance is
Yeah,
power.
yeah.
Correct. solar irradiance is power and solar radiation is energy.
Yes.
And let's say if I am at a site which has around 1 kilowatt hours per day solar insolation.
Big
How
sun hour.
much solar insolation? How much solar radiation we have per year? We have 1 kilowatt hours per meter square solar insolation. Let's remember the solar insolation is the solar radiation in 1 day. So how much the solar radiation in a year?
We have to multiply.
Yeah. So what will be the
Same.
answer?
We have to multiply by 365 for the days of the years, and you will receive the total, or we will receive the solar insolation for 1 year.
365
It's
kilowatt hour.
1,000.
Yeah,
No.
365 because it's 1 kilowatt hours per square
Yeah.
meter solar insolation. So 1 by 365 is correct. So,
Yeah.
and if we have 7 kilowatt hours of solar insolation, 7 kilowatt hours per square meter of solar insolation, how many sun peak hours we have?
7 hours.
7 hours, correct. Very good. So I see you are you're following with me very well. Which is bigger, a cell or a module?
Module.
Module.
How do we make a module? Do we connect cells in parallel or in series?
In series.
In series.
And series. We connect them in series.
Okay,
both.
very good.
In both, I see.
No. Series. مش in parallel.
In series. We
In
connect the
series.
cells in series
series.
to have a model.
Yes.
Yes.
We will talk a bit more about that. There are some certain stuff that we need to keep in mind, but in general, yes, you're right. We connect them in series. Okay, now we will start talking about PV modules. And again, as we spoke a bit earlier, in the solar modules, by the way, sometimes they call them solar panels, solar modules.
Could you
It's
share
always
Could you share the screen?
it's not visible.
For me, not.
I see it.
It's still on
I
the
see.
questions slide for me, but maybe it's slow.
Okay. Stan, you said you see it. Is it on the solar photovoltaic power
No,
slide?
it's still the questions slide.
Okay, let me stop and share again.
In the posting.
Okay, how about now, guys?
Nothing on the screen.
Okay.
Still
It is
dark
okay
for me.
now. It is okay now.
I think it's just lagging that it's coming.
Yeah, maybe we all shut off the video so we get better bandwidth for the presentation.
Yeah, I think I need to complain to Hydro. They don't have speed internet.
Yeah.
But now, Stan, do you see the solar photovoltaic power slide?
No, still nothing for me. It's still dark, but
Yeah.
maybe it's my connection.
It is clear. It is clear now.
It's
Okay.
also
Solar
It's still loading.
photoelectronic power.
Okay. How about you, Naeem and Mariana? What do you see? Which slide?
Strange, we don't see.
We also explain about the internet connection. But if everyone else sees it, then yeah, great.
Yeah,
Okay,
you all
there's
can
nothing.
see it except us.
There is nothing on the screen now.
Okay, Naeem, maybe you try to share the screen. Let's see if it works better from your side.
Okay, let me try. Yes, can you see it?
Yeah.
Okay. Just feel free if you want me to from one.
Or you can just take control and then you can move it.
That's what I'm trying to do.
Okay.
Okay, I'm not able to get control. Okay, so Naeem, if you move to the next slide, please. Yeah, so as we spoke before, the PV modules work with the photoelectric effect. So it converts directly the solar radiation into electricity without any intermediate stages. No mechanical, no moving part, nothing is happening. It's one of the few examples where you really don't need, for example, to rotate a mass or a turbine or anything to generate electricity. You just have radiation and then you get energy immediately. You get electric energy. So that makes it one of the most simple systems that are out there to produce electricity. Okay, now if we go to the next slide. And here again, we talk once more about how do we make the modules. So to make a module, we bring the cells and we connect them back to front, because the back side, or at least in the old days, it used to be the minus, the negative, and the front side is the positive. And when we connect negative to positive, this means we are connecting in series. So you were right, guys. When we are making a module, we connect the cells within that module in series. And then we form what we call a string. And in a string, we connect the negative to positive, or which means also in series, the modules. So modules that are connected in series, we call them a string. And we will see during the design that one of the first things as system designers has to figure out is what is the length of a string, of the strings that we are using in our system. And then the array is the total, is the whole number of PV modules that you have. So all the strings that you have at, let's say, one single roof or at one plot of land is what we call array. So an array is bigger than a string is bigger than a module. A module is, of course, is the combination of the cells that are forming it. Okay, can we move to the next slide, Naeem? Now we will talk a bit about some electrical parameters, main electrical characteristics of the PV module. Let's keep in our mind always that whenever we are reading any parameters of a module, these are at the standard test conditions. So if someone tells you or sells you a module that makes 250 watt peak, it means this module can produce 250 watt under the standard test conditions. And these standard test conditions are a radiation of 1000 watts per square meter. Is that correct, what I said?
Could you repeat again?
I said the standard test conditions, the radiation is 1000 watts per square meter. That's wrong. That's wrong because if we're speaking
Radiance.
about
The
Radiance.
not the radiation.
exactly, so
Radiance.
the irradiance has to be 1000 watts per square meter. That's one of the standard test conditions. The other one is 25 degrees ambient temperature. No, cell temperature. That's always what we need to remember. We never talk about ambient temperature when we're speaking about the standard test conditions. Of course, there is a third one, which is called 1.5 air mass. I think we will talk about it in another slide in the near future, but we did not want to confuse everyone explaining it during the introduction. We will talk about it later. So if you have a module and the module says 250 watt peaks, it means it can produce 250 watt under the standard test conditions. Now, why do we have standard test conditions? Because this is the best way if you want to compare different products. For example, if you have a module and the supplier tells you this module can make 400 watts, yeah, okay, but is it better than a module that makes 300 watts? We don't know if each one of them is coming up with different conditions. That's why in the solar industry, we have the standard testing conditions, STC. So you are able to compare the different modules from different manufacturers in an easy way. And when we are speaking about the main characteristics of a PV module, we should always remember the IMP, which is the current. I is always for the current, and MP is for the maximum power point. So IMP is the current at the maximum power point, and the VMP is the voltage at the maximum power. And if we multiply these two, we get the maximum power of the voltage of the module, because the power equals to current multiplied by voltage. Also, some of the most important parameters are the ISC, and that is the current, the short circuit current of the module, and the VOC, the open circuit voltage. Now, if we look down at the bottom part of this slide, we see a curve. We see two curves, in fact. One of them is called the power curve, and the other one, the power curve in blue, and the IV curve, or the current voltage curve, which is in red. Now, if we look at this curve, we will see the short circuit current. Do you see where the short circuit current is? Or how much the short circuit current of this module?
8 amperes.
8 amperes. So at the point where our IV curve is intersecting with the current axis, that's where we have the short circuit current, because at that point we will have 0 voltage. And how much the open circuit voltage of this panel?
40
volts. So in this case, this is the open circuit voltage of this panel. If there is no current, if we bring a voltmeter and we connect the voltmeter into the positive and the negative of the panel without any electricity generation, if we are under the standard test conditions, we will get around 40 volts. Now, if we multiply the voltage by the current for each of these points, we will be able to draw the power curve, the one we see in blue. And at the maximum power, at the highest point of this curve, this is, we call it MPP, or maximum power point. And if we intersect this point with the voltage axis, we get, what do we get in this case?
V at the maximum power point.
VMP, Correct.
33 volt.
Around 33 volts. That's correct. And if we take as well this point, the maximum power point from the IV curve, and we intersect it with the current, we get what we call the maximum power current, which is around maybe 7 in this case, or 6.9, something like this. So to remember, open circuit voltage is the voltage of the panel under the standard test condition when there is no current is being generated. Just when we bring a voltmeter and connect it to the positive and the negative. The short circuit current is when we short circuit the panel. We connect the positive and the negative, and we measure the current that's happening there. The maximum power point, the maximum power current and maximum power voltage happens both when we are operating at the maximum power point of the panel. Now, how do we do that? I think we will hear more about it when we're talking about the inverters and the MPP inverters, because these inverters, they try always to find this point and operate at this point. Okay, now, Naeem, can we move to the next slide, please? Now, let's talk a bit here. Of course, the IV, we see here on the right side, a number of IV curve for the same panel, but under different radiation conditions. So the IV curve is not something set in stone. It's not something that doesn't change for the panel. It changes all the time, depending on the temperature, depending on the radiation, on what's happening to the panel. So we see here on the right side, which one seems to be changing more for you when we are changing the radiation? Do you see the voltage changing more or the current changing more? Let's compare, for example, the one in red and the one in yellow.
The current.
Yes, you see it's almost linear, the relationship between the radiation and the current. So for example, when we had 1000 watts, we had around 3 amperes for the 3 amperes for the short circuit current. But then when we dropped the radiation to 600 watts, this number dropped to almost 1.7. While the voltage is almost the same. It was around 22 for 1000 watts, and then it dropped to around maybe 21. So it did not change a lot. So from here we see that the voltage really almost doesn't change if the radiation changes, while the current changes a lot. And of course, when the current changes, it means the power is changing a lot, the same. If we look down below here, we see also the relationship between the power and the IV curve, which is obviously, since the power is current multiplied by voltage, if the current is changing a lot, we will also have the power changing a lot. Okay, next slide, Naeem. Now here we are looking at the IV curve, but with different temperature. So we saw how it changes with a different radiation. Now we are looking at it into different temperatures. Now, what do we see from this from this curve here? First of all, let's compare two of them. Let's compare the most extreme ones. When the temperature is -25, that's the blue one on the right side. And when the temperature is 75, that's the red one on the left. What do you think about the voltage? Do we see the voltage increasing or is being reduced with the lower temperature? Where do we have higher voltage? At the lower temperature or higher temperature?
The lower temperature.
Exactly, that's correct. And where do we have higher current?
In the higher temperature.
Exactly. So that is very clear from these curves here.
Higher radiation.
Okay.
Now we are fixing the radiation. The radiation is the same. We are only changing the temperature. So with the temperature change, the current increases. Is that correct?
Correct.
With the temperature dropping, the voltage increases. Is that correct?
Yes. But the change in the voltage is significant. And on
Exactly.
the other hand, the change in the current is not significant.
That's very accurate. That's very accurate. So while the voltage really changes dramatically with the temperature, the current changes slightly only. But what do you think about the power in this case? How much would it change? Or would the power increase with the increased temperature, or would it drop?
It would drop to the half almost.
It would drop. Why do
Yeah.
you think it will drop?
Because there is a change in the voltage. The voltage is a drop and the current is the same almost. So when we multiply them to have the power, it will decrease.
Exactly. So if one of them is dropping and the other one is increasing, and as you see here, the drop in the voltage is way higher than the increase in the current, so the power would drop for sure. We will see all of this when you start looking into the data sheets of the modules and looking into the different coefficients, the voltage and power coefficient of the module. Okay, can we move to the next slide? Thank you, Naeem. Okay, now basically what we are doing here, we are again talking about the IV curve, but in this case, we're not looking into the IV curve of let's say one module, but we are looking into different configurations. So the one on the top, what do you think? This is an IV curve of what?
Of 3 connected models in series.
Okay, and when we connect modules in series, what do we call it?
String.
String. So here we have the IV curve of a string. And obviously, when we connect panels in series, what do we add, the voltage or the current?
The voltage.
The voltage. So if they are all the same voltage, in this case, it will be 3 VOC. We will multiply the voltage by 3. While down here, this is not a string because the panels are not connected in series. We can call this an array. What happens here? What do we add?
Current. The current. Yeah.
We add the current.
Yes.
Since we are connected in parallel, the voltage remains the same while we add the current. So here, that's why we have multiplied the short circuit current by 3. While here on the right side, here, how many strings we have? 3.
3 strings.
3.
And how many arrays we have?
3.
1.
No.
Naeem, if we go back to the slide before.
One array.
One array. Always array is everything we have. So we have 3 strings and 1 array. And how many, what would be here? What would be happening? We are multiplying both by 3. We are tripling the voltage and tripling the current, multiplying it by 3. Because we are connecting 3 for the current, 3 for the voltage in series, and 3 because we have 3 in parallel for the current. If I have 5 by 6, 5 in series, what do we multiply in this case? The current or the voltage by 5?
The current by 5, the voltage by 6. The volt.
If we have 5 modules in a string, it means we multiply the voltage by 5. Yeah. Okay, now let's go to the next slide. 9, please. Now we'll be talking a bit quickly about the shading. So, shading within one module. Now, on the top, you see on the top left, there is no shading. Here, what happens to the voltage? What would be the voltage equal to?
Multiply by 6. By 6. The voltage of 1.
Here in this case, it will be the one voltage. No, it will be the voltage multiplied by how many of them? We have 36 cells. So we need to multiply the voltage of one cell, if they are all the same, multiply it by 36, and then we get the voltage of the PV module. Because also I need you to think of a PV module similar way of a string. But instead of being made out of modules, it's made out of cells. So in this case, the module voltage is going to be equal to the voltage of all of the cells that are forming it, because they are all connected in series. So what happened if there is one of the cells that is covered? What will happen in this case for the output of the module?
The volt will reduced by the volt of this module or this cell.
Let's talk a bit about the current. It's more important now to talk
The
about
current
the
will
current.
reduce.
What will
The
happen?
current of this module will reduce, and it will control the whole string.
So, but first of all, let's talk about the current when there was no shading. What would be the current of this module in this case? Is it going to be the current of the 36 cells, of one cell, or 12 cells?
The current of one cell.
The current of
The
one
current
cell.
of one module.
The current of the module will be equal to the current of the cell.
Yeah.
While on the right side, if one of them is covered, then which current is going to be happening in the module? Which will be the current flowing in the module?
The current of the shading cell.
Correct?
0.
Exactly. To avoid that, this is why we have what is called bypass diodes. We have a bypass diode. So if you see here on the left side here, down, if one cell is shaded, then the diode will disconnect all this part where we have the shaded cell. In this case, we will get half the output, right?
Yes.
Right.
But it's better than nothing. And it all depends on how many bypass diodes we have in the module. Usually we have 3 bypass diodes. So in case one cell is shaded, and if it's the right in the direction of the bypass diodes, we will lose 1/3. Yeah, Maria, I see you raised the hand. Sorry.
Yes, sorry. I think I didn't fully get why that will be better than having one module shaded, like because the output is not going to be 0, right?
In the one on the left down?
No,
Yes,
no,
the
on the
output
shading one,
on the
where you
shaded one,
don't
the
have a
output
bypass diode.
It will be 0. The output
It
will
will
be
be
0.
But why exactly?
Because when we are connecting strings, or when we are connecting cells in series, we have only one current that is flowing in that
Right.
series, in that
Yeah.
circuit, and it will be the lowest one. And since one of them is shaded, that current is going to be
Right.
controlling. That will be the current flowing in the whole circuit.
Okay. Yeah, got it.
Okay, Naeem, can we move to the next slide, please? I'm afraid I'm a bit slow now. Maybe I should go a bit faster. Now here it's just some numbers so you know the difference between crystalline silicon and thin film. Of course, the thin film is like there are so many technologies that are under the thin film. Amorphous silicon, cadmium telluride, CIGS, these are all thin film. And here we're not only talking about silicon thin film. So there are many technologies there. When we're speaking about efficiency, if we want to compare them, obviously the crystalline silicon is higher. It can go up to 24% efficiency. But if we're speaking about the power temperature coefficient, we see, if we look at the unit of it, we will understand what it means. It's percent for each degree centigrade. So if it was 0.45 minus, as we see in the crystalline silicon, it means for every increase in temperature above 25 degrees cell temperature, we are going to be reduced, our power is going to be reduced by 0.45%. Why it's reduced? Because there is a minus here. We see that this number is a lot higher than that for the thin film. So my question to you will be the following. If you have two modules, both of them have an efficiency of 19%, so they are almost the same. One of them is thin film and one is a crystalline silicon. Which one will produce better in a higher temperature ambient?
Thin film.
Correct. And which of these thin film technologies will be the highest? Amorphous silicon or CIGS?
Amorphous silicon.
Amorphous silicon. That's correct. So thin film is less sensitive to temperature, to high temperature than crystalline cells. Okay, I think with this I will conclude, Naeem. I need to leave some time for you guys. I'm talking too much. So just if you show me quickly what's the next slide, but I think I will have, yeah, I think we can look into these numbers. The guys can look into it. There's not much to talk about it. It's just majority is now bifacial. That's what we see happening all around the world in comparison to reducing the monofacial cells. Okay, if we go to the next slide. Yeah, and here we see data sheets. I think we'll be talking more about them in the other presentations.
And this part also, Michelle, will be covered at the
exactly
design time. Yeah.
Yeah. Yeah. So I think these 3 slides, that would be, yeah. Any last questions, guys? So just quickly to summarize it, if the temperature increases, the voltage increases or reduces?
Reduced.
And the current?
Increases by a small value.
The power?
Will decreases.
Will decrease. Okay, very good. Then I think the guys are doing very good job. They are paying attention to everything, Naeem. I could not trick them. So it's your turn.
Thank you, Michelle.
Thank you.
Yeah, so I will cover the next part, which is about the inverters. We'll try to summarize the things because of the time. And just for your information that these topics will be covered deeply in the other sessions in the future, because we will have a session for design where the trainer will walk you through data sheets and the selection for the right equipment and so on.
Yes, just I think we'll do a small change. That Stanislas will take the mountain systems together with his
I can go back to the inverter.
Yes,
it's
so
okay.
there is more time.
Yeah,
I think that's
because Stan needs to go to something else. Stan, do you want me to keep sharing my screen or you will share from your side?
No, I think, Naim, the plan was you go on with the inverters, that makes sense after the modules, and I will take the introduction to mounting systems in my Wednesday presentation, if everybody agrees.
Okay, that's fine.
And I will
Yeah.
stay now. I just have to go at 11:30 sharp. But then we will do the introduction to mounting systems and balance of system on Wednesday.
Okay, that's fine. It's okay.
Very good.
Yeah. So the last part of today's session will be covered by Stan on Wednesday, because he's the one who's going to cover the next session. So he will we will not cover it today. So I will cover the inverter part, and then we leave the rest that can be covered on Wednesday. I noticed that someone raised the hand. Anything? Any question? Any point before we go ahead? Okay.
I have a question about shading. I don't understand what is shading clearly, because he wasn't use indicator in when he explained this.
Yeah, I didn't get the point, but and as mentioned, like these topics will be repeated in deep details in the next sessions. I think on Thursday session, where Michelle will be again talking about the design and doing the right selection for the equipment. Also, Stan will be talking about the site preparation on Wednesday. And also he will talk about the impact of shading and how to avoid it, or how to deal with shaded sites and locations. Yeah, Engineer Mahmoud. Engineer Mahmoud. Mahmoud, you raised hand. Any question? Any point? Mahmoud? Okay, so as Michelle talked about the modules, and we noticed that the changes due to weather conditions like temperature and others, and you see these differences. So we can notice that the solar energy is not fixed; it is affected by the weather, and by default we need to have something to regulate this. And another thing is about the loads, because we know that all of our electrical loads at home, factories, and other applications are AC. And what solar modules generate is a DC current that is not used directly for around 95% of the applications around the world. So this is why we need a device that can deal with this variation and the fluctuation from the source, which is the solar modules, and also arrange fixed stable power, AC power that feeds our loads. This device is an inverter. So the main function for the inverter is to change the electricity from DC to AC. This is the main function. Now, the other functions that will come in the next slide, and we'll talk about them, but this is the first thing to know about the inverter. So we know about the first part, we know how the modules converts lights to DC current. Now we come to the other part, the other important device that converts this current and this power that comes from DC modules to AC. That power we are familiar with in all of our applications. There are different types of the inverters, and these types mainly can be categorized based on the application. And each of these types has a lot of subtypes based on the functions that are related to the design parameters and others. So the main three applications or types of the inverters are the grid inverters, grid type inverters that are on-grid inverters. And the meaning comes by the name itself that these inverters cannot operate, but only with a grid or stable power or stable source of power. So it generates electricity or converts electricity from solar modules and injects it to the grid or to the network that is connected with. In case of an absence of grid or stable grid, these inverters don't work. Even if it is at the midday, you have sunlight, you have solar modules connected, but the grid is not stable, you cannot use these inverters and you don't get anything from these inverters. The other type are off-grid inverters. Off-grid inverters are installed in the areas where there is no electricity or there is no electricity or grid, or there is no stable grid. So we use off-grid systems or off-grid inverters that comes with batteries. Now, off-grid inverters comes with two types. One of them are purely off-grid, just an inverter, batteries, and solar modules, and the other type called hybrid inverters. Hybrid inverters comes with you can say a combination between purely off-grid an island inverter and grid inverter. So the hybrid inverters can deal with batteries, grid, and diesel generators. So these type of inverters are highly recommended in the areas where there is a grid but not stable, and the areas where the application needs an availability or an existence of diesel generators or other source of energy. The main function of the inverters is to you can say that handling the fluctuation that we have from solar source, from solar modules, as presented by Michelle. For solar modules, there is always fluctuation. You don't get stable current, you don't get stable voltage, and the inverter actually handles this and deals with these changes and always takes the best point to make sure that it delivers a stable output power based on the type of the inverter, as mentioned in the previous slides. If it's on a grid, off a grid, or hybrid inverter. It converts energy from DC to AC. Also, it automatically synchronizes the system with the other source of power. If it's on the grid, it synchronizes it with the grid. If it is off the grid, it synchronizes or it connects and manages the power coming from the solar modules. It manages charging the batteries and delivering stable power and so on. For some of the inverters, the advanced inverters, there are other more applications and functions that comes with monitoring of the system, where you can easily connect the inverter to an application that is owned by the manufacturers, monitor the system, and so on. So all of these functions come from the inverters, but it depends on the inverter type actually. So we talked about this in general, but these like sub types of the inverters. So the most common inverter that's available now for on-grid applications, you can say for small residential applications, small commercial and industrial applications, that's commonly used, which is called string inverters. So for small systems like up to 1 mega, 1.5 mega, 2 mega, it is highly recommended to use this type of inverters, the string inverters, where you connect a group of inverters in parallel together. You have more access to the DC part by using the string inverters because it comes by the name itself. So you have access to each string of the solar system, and you get the highest energy or power coming from solar system compared with the second part, which is central inverter. Central inverter actually is not commonly used, you can say, in Palestine or in our area, because we don't have a huge scale or utility scale systems where they are there in other countries in the region like Saudi, UAE, and others, where you see like a huge solar farm for solar modules, and even in gigawatt capacity. All of them have same tilt angle and other situation where you don't have differences between strings. So they use central inverters that comes in mega size. Off-grid inverters, as mentioned, they convert DC to AC. They manage storing energy in the batteries and supply stable power to the loads. Grid forming inverters actually are the important inverters. Even now they are recommended for on-grid applications, not only off-grid. And it is good to know about it. Maybe you guys heard about the shutdown that happened recently in Europe, in both countries that have the highest renewable energy penetration in the grid. Renewable energy was not the reason for this shutdown, but when they had a fluctuation in the grid because of other reasons, the current on-grid systems couldn't handle this fluctuation, and the whole on-grid systems shut down. So they had like big blackout because the power that they have, which covers actually in Spain and Portugal, I think more than 50% of their national power there. But this available source of power couldn't support them when they had this fluctuation at the midday, where it was fully shiny day. So the solution for this, which is highly recommended now for the systems that are connected to the grid, especially big systems, is to use this type of inverters. For the basic application, it is same like other inverters. It converts from DC to AC, it synchronizes the grid and so on. But the additional stuff for this type of inverters, that these inverters can handle and deal with the fluctuation in the grid. It can start the grid, it can initiate grid. You can say between brackets, it can, for some cases, it can operate same like diesel generators. When you have sudden load, as an engineers, maybe you deal with diesel generators. When you have sudden load, the diesel generator can absorb this load and react to cover it and then stabilize the grid. The traditional on-grid and off-grid inverters didn't have this function, but now this function is already there in the grid forming inverters. It can handle such loads and fluctuation in the grid. Also, you will see this later on when you read about, can say, or get information about selection of the inverters. You will see the differences, and you will see the main parameters, the operation parameters for the standard and normal on-grid inverters and the grid forming inverters, and you will see the window for these parameters is much bigger for grid inverters, where it can deal with big fluctuation and changes in the grid compared with the standard inverters. Yes, Mahmoud. It's Muhammad, sorry.
Hi. Do you mean that the grid forming inverter, it's the same of the VFD, which control the pumps and so on?
No, actually not. VFD is a motor starter that's used at the load side to manage the high starting current. So it manages the starting current where the grid or the power source doesn't sense starting current, and it starts in steps by managing the frequency. But the grid forming inverter is the source. It can deal with the fluctuation in the grid. It's not only about the current or voltage, it is about all grid parameters. This includes frequency and others. So both of them are totally different. VFD is about load, and this inverter is about the supply.
Yes, but we have some kind of inverters that's called agriculture inverter. I think it's the same of the grid forming inverters, because it's control the frequency and the voltage at the same time for the load upon the radiation comes from the sun.
Yeah, that one you are talking about is different from this one. That one is called VFD inverter that comes with a solar pumping system. So it operates the pump while you have solar. So at the morning time when you have like low radiation, it runs the pump with a low speed. And then when you have more sunlight, you get more speed for the pump. And at the end of the day, same thing. So that one is different application. That one is a combined, you can say, a starter with an inverter, and it's customized for a specific application, which is solar pumping system. But it's not designed for a grid or for different. Yes.
معلش مش انا عملت لكم يمكن نويزز او انتربشن. انا كان عندي بس سمعني الان؟
سامعك.
طيب جيد. اول شيء تحياتي للجميع. والله يعطيكم الف عافيه. ما يمكن ما صحش لنا فرصه انه نعمل، خلينا نقول ترحيب بيكم وشكر مقدم لكم لكل المشاركين في الدوره. بس انا حبيت اكد على جزئيه انه نحاول نعمل عملية ربط مباشر للمحتوى الدورة بالتوقعات اللي مطلوبة لمعالجة الحالة عندنا في غزة. أنا عارف إنه أكيد أنتم ماخذين هذا الجزئية بعين الاعتبار، بس واحدة من الشغلات اللي كتير مهمة أنا بس حابب أذكر فيها إنه إحنا في حال بنصمم وبدنا نبني منظومات طاقة شمسية، بدنا نحاول لاحقاً انه ينعمل لهم انتجريشن بحيث انه يكونوا لنا حاجه زي مثلا محطات جزئيه او 1 ميجا. يعني فقط هي الجزئيه اللي انا بحاول اكد عليه، انه نعمل ريفليكشن لكل النولج اللي بدها تمر في الدوره بحيث انها يصير لها براكتيكال دايركت براكتيكال ترانسفير لجزئيتين اللي هي يعني مع اللوكاليتي. يعني بدي اعطي مثال بهمش. لما احنا مرينا على جزئيه موضوع اثر الحراره في علاقتها العكسيه مع الفولتيج، ممكن احنا تلقائيا نعمل ريفليكشن. هذا مرتبط في موضوع اختيار المواقع انها تكون وين بتكون عندنا.
بس احكي لك باشمهندس عشان الوقت، ممكن اجاوب بالانجلش. بس ممكن بس اجاوب بالانجلش. The point here, we explained this at the beginning, that this training is mainly for your application. It is designed for what will be done in Gaza. This session is a general introduction session. It is important for engineers before they get the next session, which is about site preparation, that they know at least about the main components and the differences between these components. So when it is mentioned in the next session, they know about it. So that the trainer in the session, let us say on Wednesday, my colleague will be talking about the site preparation and the site challenges and so on. When he talk about shade, such an example, he doesn't need to go back and talk about shade because it is covered, you can say, today. When he talk about inverter, he doesn't need to go back and talk about types of inverters. So you can say it is a series. We will have 5 sessions, and this is just the beginning. This is introduction. It is mandatory and important for all engineers who will be with us in the next sessions.
Excellent. Thank you so much.
Yeah. So I'll try to summarize this quickly. Because of time, if you remember when Michelle was talking about parallel and series of solar modules, it is again repeated here because for each inverter, it has a parameters for the voltage input and the current input from the solar modules. So let us say if you have a specific or a type of solar modules that you get there in the market, and you have an inverter, so you need first to check for the inverter, what are these parameters, what is the average DC voltage for the inverter, and what is the current input for the inverter that are acceptable or that is acceptable by the inverter, and then you arrange the parallel and series arrangement of solar modules on this base. Let me give general example. I was actually planning to do it together, but I will try to run it quickly. If you have 10 kilowatt inverter where you have an average voltage, let us say 500 to 750 volt DC, and you have a current input of 20 amps, and you get a solar module 500 watt peak with a voltage 45 volt and I short circuit, let us say 8 amps. So you need to use these modules, connect them to this inverter and make sure that they are compatible. You start with a voltage. You have range 500 to 750. Then you have the voltage for the module 45 volts. That means you need to go with minimum 11 modules connected together in series to reach a voltage that is higher than the minimum. Usually the minimum voltage comes lower than this. I'm just giving random example. It comes less than 500, but it is just an example. So that means you need to go with a voltage within the range. It means you go with 11, 12, even more. So the total, yeah.
Could you slow down a little?
Okay. Yeah, sorry.
You are talking very fast.
I'm trying to, yeah.
It's not a problem on this side if we go over
Okay,
time. So
okay,
I mean,
that's
if
fine.
people are okay to
Okay.
stay, then you can.
Guys, are you
talk
okay
forward.
with the time? So no one has any other commitment? So, okay. So let me repeat the example again. So let us say you have an inverter that you got there in Gaza, which is 10 kilowatt, and you got modules with 500 watt peak. So first you check the voltage input for the inverter and the current, which is there. My colleagues will cover it, but you will see it in the data sheet about the PV side for the inverter. You will see the voltage and current. That are the most important things, in addition to other parameters that will come to it later. But I'm just trying to explain how we do the parallel and series. Series always related to the voltage. So if you have module that has a voltage, let us say 45 volt, and current, the I short circuit 8 amps, while the voltage for the inverter, let us say 500 to 750. That means you need to make an arrangement for the solar modules where the total voltage, the sum of the voltage in series, to be within the average or the range for the inverter. So if the inverter data sheet says that the input voltage should be between 500 to 750, then you make arrangement. For the given example, you have 45 volts for the VOC for the solar panel. That means you need to go with 11 plus. So 11 is almost around 500. So you need to go with 11 plus in the arrangement just to be within the range for the acceptable voltage for the solar panel. Then you check the power. You say, okay, I have 10, 11 modules, 12 modules connected in series that you can say arrange the voltage that is okay with the inverter, but I'm not achieving the power. The total power is the sum of the power for the modules. We gave an example of 500 watt peak. So if you have 11 panels connected in series or 11 modules, you get 550 watt peak in 5.5 kilowatt peak for the 11 panels. You get the voltage within the range of the inverter, but still the power is not matching with the inverter power. You have 10 kilowatt inverter. Then you consider another series that is to be connected to the inverter, another string. This series called string, where the current for both of them doesn't exceed the input current of the inverter. So you have 11 modules connected in series. Then you have another 11 modules connected in series. This one has voltage same like the inverter. The other one has voltage same like the inverter, then the range, and the current, when you connect them in parallel, the current will be like sum. So for the parallel, you get more current. For series, you get more voltage. So in our case, we'll have voltage around 500 volts, current around 16 amps. You have 8 plus 8. So both parameters should be within the range of the inverter. Now for the power, we have 11 kilowatt in our case. For the inverter, 10 kilowatt. Here, all the inverters actually accept up to 20% of its capacity because, as mentioned by Michelle, for the power from solar is not ideal and keeps fluctuating. So you don't, if you have 10 kilowatt of solar, you don't by default get 10 kilowatt power. So this is why the inverters have this window for over current. The other thing, if you want to stick to the inverter capacity, you can go with the string, the second string smaller than the first one. But in this case, you need to choose a right inverter that has multiple MPPT. We'll come to that point and to talk about the advantages for it. But the point here to know the arrangement of the parallel and series. More voltage, we go series. More current, we go parallel. And the power fixed. Any question about this? So the MPPT is one of the main important functions in the inverters, even the small inverters. So to summarize this point and the advantage of the MPPT, I can continue from the recent example that I started with. Let us say you have 10 kilowatt solar modules, you have 10 kilowatt inverter, and you want to connect them together. But when you make an arrangement, you find that you need to have two different strings. Let us say the first string will have, let's stick to 500 watt peak example just to make the numbers easy. Let us say the first string, you need 12 solar modules to be connected together in series. So this is the first string, while the second string is 8 modules. You cannot connect both strings in parallel together because for parallel case, all strings should be identical. When we say identical, you are using same modules, same capacity, same parameters, and same orientation, same tilt angle, and so on. When you have these two differences, you have two different strings. That means you need to go with multiple MPPT inverter. The advantage for this MPPT, when it is available with the inverter, you can connect two different strings to the same inverter, but in two different MPPTs. So the inverter will deal with each one of them separately. When it is recommended to use the multiple MPPT inverter, it is recommended when you have different orientation. For some applications used for on-grid and even off-grid, you have different arrangements. Sometimes for on-grid, people go with east-west arrangement. So you cannot connect the east-oriented modules in parallel with the west-oriented modules. For some cases where you have a challenge in the space where part of the modules will be partially shaded during daytime. So in this case, you avoid connecting all of them together because when you have one of the modules shaded, this will affect about the whole string, the whole arrangement. In this case, you separate the shaded part, connect it in a separate to a separate string to a separate MPPT. The inverter will take the maximum from this part, and when it is shaded, it will not affect the rest because the rest will be connected to another MPPT. So this is also one of the advantages for the MPPT. So when you have different strings, different arrangement, different brands and models of the modules. Let us say you get trainer modules for back again to the inverter with 10 kilowatt. You get trainer modules for 5 kilowatt, and you get the Jinko modules for the other 5. So theoretically, you say I have different modules and one inverter. What to do with this? If the inverter is multiple MPPT, and by the way, most of the current manufacturers, they have multiple MPPT inverters. except the inverters that comes with a single input that are small inverters with like 1 to 2 kilowatt and others. But the rest, you can say 3.5 and above, it comes with multiple MPPT. At least it has 2 MPPT. So this is what is there in the market, but it's important to highlight this just in case you get an inverters with a single MPPT, you know where it is applicable and where it is not. But when you have two brands, let us say, the first MPPT can get connected with the trainer modules, and the other MPPT can get connected to the Jinko modules. So you use an advantage for what you have without causing any technical issues or faults in the system. And again, for the modules in the series, you should have same modules, same parameters. You cannot use even from same manufacturer. If you have 500 watt peak module and you get 550 watt peak modules from same manufacturer, you cannot connect them in series and you cannot connect them in parallel, because series and parallel should be always typical unless you have multiple MPPT, because for the multiple MPPT, both of them will be handled separately from the other one, so they don't affect each other. Yes, Mahmoud. Yes, Mohammed, sorry.
I don't get why you said that we should have an inverter with multiple MPPT cards when there is a various strengths in orientation. In size, I think it's okay. In kind of the solar panels, I think it's okay. But why, if we have two strings with different orientations, we should have multiple MPPT card at the inverter? Because when we connect them in parallel, I think the voltage will be the same if they are the same size of the strings, and the current, it will be added. And if one of these strings has a current lower than the other, it will not affect each other.
Finish?
Yes.
So theoretically, Muhammad, what you are saying is it true? When you connect different systems, you have the like a current flow, but the advantage for MPPT, actually, I was not saying that the system will not work without it. I'm saying the advantage of having the MPPT, because when you install solar system, you need to get the max as possible of the power. This is why it was developed by the manufacturers to have multiple MPPTs, because when you have different orientations, the system will deal with the lower one always. Like, let us say if you have east-west arrangement, and the morning time, you will get you can say best for the east part. So the east part will have higher power compared with the other side. If both are connected in parallel, the system will read the power as per the lower one. So it will not get you can say the highest from the system. But if you have the east connected separately from the west, you will get the highest power from the east when it is high, and it will get the low from the west at that time. So you are not losing anything. And the opposite will happen at the afternoon. You will get the highest from the high part and so on. But if you have both of them connected in parallel, the system will deal with the lower one, because by default, you connect two systems in parallel with different parameters and take readings. You will see that you are getting readings same like the small one. The only difference will be in current, but the voltage, you will get the smaller one. And the other important and dangerous point, actually, and sensitive point, you will have a current flow from the higher voltage to the lower voltage. So you will have a current flow within the system itself. For small systems, you don't notice this, or you don't get the risk behind it. But when you have thousands of solar modules installed somewhere at the rooftop or somewhere, by time and by having a current circulation within the system itself, especially at summertime when you have high temperature, current flow within the system that increases and overheating the cables, it causes fire. So if you have a system with different arrangement that is operating for 1-2 years, that is fine. But I can tell you, you will get fire today or another. So this is why the MPPT was developed by the manufacturers to solve a lot of problems. One of them is the power and energy from the solar to get the maximum, and the other important one is about the safety of the system itself.
Thank you, I got that.
Most welcome. So the point for Gaza is about that's something we're trying actually to cover, because it is expected that the majority of the equipment that you will get in Gaza that you don't manage, like you don't have the flexibility to choose. Actually, it depends on the donors or what you will get in Gaza. So this is why we are trying to cover all the points so you will have the flexibility to deal with whatever you get in Gaza. So maybe you get just single input small inverters. You know where to use them when you split the systems. Maybe you get inverters with some inverters with multiple MPPTs. So these inverters, it is recommended you use them where you have a different orientation, where you have different brands of modules where you need to connect them to same inverter. So it's recommended that you can prioritize them from day one once you get to them and find that this is with multiple MPPT, this is single input and so on, just to make the things easy. So it's important to know about all of these points just to simplify the things for you guys. Yeah, this one we covered about the MPPT. So here, like whatever connected to a single MPPT should be same. Like you have same modules, same parameters, same arrangement, same number of modules connected in series, same number of modules connected in parallel for each MPPT. So these are different types. Here we're not making any marketing for any brand, but they are just an example. Now, nowadays in the market, there is an inverters around 250 kilowatt, but it comes with a higher voltage that are string inverters for on grid. For off grid, for a single inverter, there is up to 125, 135. If any of you works with a commercial company where you will have flexibility to order equipment to use them in Gaza, so you can consider capacities. You have like up to 125, 135, and higher than this comes like a PCS, where you have a single inverter that covers 200, 250, 500, 1 megawatt, and so on. I'm talking about off-grid inverters, but for on-grid, the maximum I know as string inverters we have in the market like 250, and some manufacturers are developing now 350. For off-grid inverters, which is expected that most of the systems, at least at the near stage in Gaza, will be off-grid. As mentioned, for off-grid, there is a purely off-grid system where it is a simple system where you have an inverter, batteries, solar modules, and load. This is the basic application, and usually small size inverters comes with this under this category. And the other type for off-grid, which is hybrid, and the majority of the inverter manufacturers are manufacturing this kind of inverters nowadays. For hybrid inverters, you have the basic concept, which is batteries, solar module, and load, but the additional stuff that you have with hybrid inverter, that the inverter itself has a capability to be connected to a diesel generator, and even it sends a command to generator to start when the battery's level reaches a certain level. If you use diesel generator as a backup to charge the batteries, or if you use a diesel generator to run in parallel with the inverter. Also, if you have a grid, and I know this was a challenge in Gaza even before war, where it was occasionally to get a grid power in some time, not all the time. So the hybrid inverter can be connected to the grid, and also it can control getting power or prioritize the power source from the different sources that is available. So I'm expecting if you get such systems in Gaza, I'm expecting that the majority of them will be hybrid because most of the manufacturers are manufacturing hybrid now. This is the large inverters. For on-grid, it is called central inverters, where you have 1 mega, 1.5, 2 mega, 2.5 as a one set inverter. This is used for utility scale systems where you have same orientation for the system. If it is south-facing system, such an example, if it is east-west and big, so they use all the east connected to one centralized inverter, because such inverters don't have the MPPTs, and the other side connected to another inverter, and both of them connected in parallel. For off-grid, as mentioned recently, there is a PCS systems that are equivalent to this. PCS is a big off-grid inverter that is connected also to big systems. It is used for utility scale systems when you have solar systems in megawatt scale, and you have batteries. These systems where the inverter needs to charge the batteries and feed load 24/7. This is the on-grid type systems. So the on-grid systems doesn't work without grid. So it's important to have stable grid, as mentioned at the beginning of the inverters presentations. It's important to have stable grid with less or minimum fluctuation, or at least the recorded fluctuation to be within the acceptable ranges of the inverters that you are using. Such an example, inverters accept a percentage in fluctuation. You will see it in the data sheet, plus minus, let's say 1%, 2%, 5% in the voltage. Also, there is a certain percentage for the frequency and so on. So for the areas where there is a fluctuation higher or lower than this range of the acceptable range of the inverter, in this case, the inverter will trip and keep tripping, and you may face case as mentioned in Spain or Portugal. So this is one of the key important things. So it is not just to bring an on-grid inverter. If you have a grid, you install it, connected, and it's fine. The point is that the exercise start even much before you reach the level to size the inverter. You need to study the grid. Inshallah, in the future, you get a stable grid in Gaza, and you reach a level where you install big on-grid systems. And it's important to do such analysis before you design any system. And I know some of you work with municipalities and authorities. So this is important things, even when you deal with the contractors. So before you design any system, you need to analyze the grid and get these parameters and make sure that the selected inverters or the proposed inverters by the installers are in line or can handle and keep operating within these fluctuations. If not, it's recommended to go with the grid forming inverters that has wider range of fluctuation and can even improve the grid in some areas. I'm talking about the grid forming inverters. Yeah, I noticed someone raised hand. Yeah, Nida.
I want to ask a question about the subscription in Gaza, which had signed the net metering agreement. The inverters were on grid. Yeah.
Okay.
In our current situation, how can we come over this problem?
You have. Continue, please.
In other words, I want to ask, solar systems were sufficient in this case, or it was cannot operate in our electricity blackout?
so now for the current situation, because the grid is not there, so these systems will not work. If you are talking about the existing systems that were installed before war, right?
Yes.
Yeah, my recommendation for these systems, you have solar modules. Solar modules are same. If you have on-grid, off-grid, or whatever application in solar systems, solar modules are same. So there is no special modules for
Yes.
on-grid, this is an example, or off-grid. My recommendation for this, wherever you have an existing systems that the solar modules are still healthy, and you have the inverter there, you either replace the inverter with an off-grid or hybrid inverter. So in this case, you get benefits from the system, the solar system that's already there. And you use this energy in another way, where you have a hybrid inverter that supports charging batteries, and then you use it 24/7. If this is not possible, you know, on-grid inverters, there is a sorry, because there is a back noise. But if the changing these inverters or replacing them is not possible due to availability or cost or whatever, these inverters, as mentioned, they are on-grid inverters, so they need a grid, but they are not smart enough to know like the type of a grid that is there. So given that, if you connect these inverters with a diesel generator, but by using a proper controller, you still can operate the system, because the system will see the power coming from diesel generator as a grid. Also, another thing that you can do, you bring another small off-grid system. If you have, let's say, 500 kilowatt on the grid system installed somewhere, you bring a system, a 20 or 30 kilowatt off-grid system with hybrid inverter, connect it in parallel to this system. The existing system will see the power coming from off-grid system as a grid, because it needs stable voltage, stable reference voltage to start injecting the grid. So the on-grid system doesn't generate electricity by itself, but only it injects power to a stable grid. So you need to create like a fake grid to these on-grid systems to get energy from them. But this can be used only during daytime, when you have, you can say, a sunlight, and that's it. You cannot use them at night or other times. Yenida, you still have question?
No, thank you. It's clear.
Is it clear?
Yeah, it's clear. Thank you.
And to add to this, Nida, if you replace it, don't know if you work with the authorities or a private company, but anytime, anyway, if you replace this, or if you plan to replace these inverters, my advice is to replace them with hybrid inverters, because once you have a grid back, inshallah, coming soon and in the future, once you have the grid back, the hybrid inverters can operate same like on-grid inverters. That means most of the hybrid inverters that are there in the market now, they support feed-in, which is to feed power back to the grid. So this is there in the hybrid inverter. So if you plan to replace them, it is good to have such inverters, so you can use them now with the current situation, and you use them in the future.
What about injection the electricity into the network?
Yeah, they support this. Yeah, they support the hybrid inverters. Most of them, it is not general, yes, but most of the current hybrid inverters in the market, they support the feed-in option. Like if you install them where you already have a grid, and by the way, this is not necessary to be in areas where a problem in the grid. Most of the countries, even Austria and some European countries, they have an initiative where they encourage people to install solar system at their houses using hybrid inverter, and they can sell electricity to the grid. Even people do trading, by this. They charge their batteries when the tariff is cheap, because the tariff is not fixed in most of the countries, not like us in Palestine or most of the Middle East, the tariff is fixed. The other countries, they don't have fixed tariff. So most of people, they do trading. They charge their batteries through their hybrid inverter when the tariff is cheap, and then they export back to the grid when the tariff is high. So they do this. And for the grid, this is important to stabilize the grid at the peak time. So you can say it is win-win. So yeah, so the hybrid inverter actually is recommended in this case. You use it now when there is no grid. You charge the batteries that hybrid inverter can do, and you feed your load. And in the future, when you have stable grid, you have the option by using same inverter to export power back to the grid, and you can control this, how much to export and so on, from 0% up to 100%.
Okay, thank you.
Okay. Yeah, so it seems that this slide was the last one. Any question? Yeah. We are ready for the questions now. Slides. ميسرة تفضل.
السلام عليكم.
عليكم السلام.
I have one question about the hybrid inverter. I think it's required a battery to work also. I'm correct?
Yes and no. I can explain now. Is there any other part of your question, or this is the only question?
This is the only question.
Yeah, so why it is yes and no, because it depends on the inverter itself. You know, there are a lot of manufacturers now. I know some brands support power generation without using batteries. So you get a stable power, but you know, also this depends on the radiation and so on. And I know others that cannot give stable output power without having batteries connected to it. So it depends on the brand and model that you deal with. But for the case that we are talking about, which is in Gaza, you need batteries by default because you don't have a grid. And even if you have inverters where you get power directly from the solar, it is a limited time because it is expected that the ideal time where you have a voltage and current inputs from solar where the inverter can give ideal stable power just for only 3 to 4 hours as an average. There is more power solar generation in the morning and the afternoon, but if you have batteries, this energy can be used to charge batteries, but not to stabilize the output voltage. So this is the point. Even if you have it without batteries, you don't get that much benefits. It is just for few hours a day.
Okay, so we are tied to PV radiation fluctuation during the day. So we some loads like factory, they need a stable power supply. If we depend on the PV fluctuation, they will not guarantee 100% electrical power efficiency.
Yes, so this is why when you use hybrid, like usually for on-grid systems, the manufacturers and the other loads don't notice this part because they usually depend on the grid to compensate when there is a shortage. But for our systems, when we talk about off-grid systems in the current cases in Gaza, you need to analyze your load and compensate the shortages by using batteries. Because if you know the curve for solar, it starts low at the morning, increases at the noon time at the peak, then decreases. You need to analyze this and link it to your load. So if your load comes within the peak hours of the solar system, that's fine. If you don't invest in batteries, you can say. But if your load is operating while the low radiation from solar, which is at the morning time or afternoon, if you have continuous operation, you need to compensate the shortages by using batteries. So the system will charge the batteries out of the operation hours, or when there is a surplus power supply from the solar, will charge the batteries and will continue supplying you fixed power within the operation time for your application.
Okay.
Yeah.
Thank you.
Welcome. Any other question in general about the inverters, about what we covered today? You can ask in Arabic, guys. It's fine. Don't hesitate. It is your training. It is for you, and it's not a training. It is experience exchange. You can say it's just a discussion. Yeah. Go ahead, Zakaria. Zakaria, go ahead. Zakaria. Zakaria.
It's possible to also write in the chat.
Yes. Zakaria, if you have problem in your mic, you can write in chat. Maybe he's trying to reconnect. Any other question, any point? Mariana just shared the link for the next session on Wednesday at the same time. So this is important to be on time, guys, just to get the benefits from this as much as possible. Unfortunately, today we had to postpone part of the training to the next session, so time is important.
So comment there.
I think it would be good to include the risks from grid for the grid scenario when using a neutral one. Yeah. So Noor, for your question, it is not faking in practically. So technically, we should not say faking, but in this, when you create a grid, it is just you create. You can say fake grid to the on-grid inverters, but technically, it is to create a grid. So the on-grid inverter can see that there is an existing stable power and mainly voltage. So it starts injecting power or energy to the grid that is connected to it. For this one, sorry. Yeah, for this one, to be able to do this, you need to have to work on the control side of the inverter. So if you have a diesel generator, usually it is recommended to use hybrid controller. It's a small device that communicates between inverter and generator to arrange the synchronization. It's the same way when you synchronize two generators, such an example, you need to have a synchronization controller just to avoid the reverse power and other stuff that negatively affect the system. If you have off-grid inverter and you have an on-grid inverter where you need to connect them together, same thing. You need to have a controller that communicates the synchronization between them, or that protects your off-grid inverter from the reverse power. Because if you have a 20 kilowatt off-grid inverter that works with the solar and batteries, it generates electricity, and you have 50 kilowatt on-grid inverter. You connect them together, both will work together, but first you start the off-grid. So when you have a surplus power from the on-grid, it sees the off-grid as a load, and it operates for some time and then trips. So it is just to use, you can say, a proper controller that can handle this. It's a kind of protection of the equipment. Yeah.
Okay, maybe read it loud.
Yeah. I'm just reading the question from Zakaria. technicians have wanted to repairing and reconnecting them. What is your opinion? And would they affect the... Yes, so Zakaria is asking important question about the damaged or partially damaged solar modules in Gaza, and he mentioned some people are using them now. Is it safe to use them? Yes, individually, but not to connect them to other solar modules, because let's take an example. If you have proper solar module 550 watt peak, and you have another one that partially damaged, if you connect them in parallel or in series, so there will be a current flow, internal current flow within the circuit. Let us say if you connect module 1 with module 2 and then connect them to a small inverter, then to load, you will have an internal current flow. It's not only the current that is going to the inverter and load, because one of the modules has different parameters from the others. Historically, or even in previous projects, we used actually to exclude the modules that has just a small crack. Even we check the parameters and we find them, even brand new modules. But by misuse of the technicians, sometimes they work on some of the modules, they cause some small crack. We used to check the parameters and we find them same like others, but we exclude them. The reason for this, because if you notice in the modules part, there is a sensitive small connections inside the solar panel. So if it is partially damaged and you check the parameters and see they are okay and they are healthy, but I can tell you like there are very small cracks that affect the welding points for these small conductors inside the module. So maybe some of them are partially damaged and they have weak connection still there. When you test, you get it there, but when you test, it's not like when they are in operation. When they are in operation, there is a high current and voltage coming from the rest of the system that is affecting this, and it will flow through this point. So when the current increases by time and you have only just a small 25, 30, 50% of this point still connected, it will overheat by time and will cause fire. I'm not sure if you guys saw videos in general, like sometimes people share videos and pictures about fire going on in some systems. And if you see an argument about this, you see the contractor, the consultant, everyone saying that we did the right things, we tested everything before we do this. I can tell you sometimes because of small crack in the solar panels, it causes a huge fire by time. And these problems, you don't necessarily discover them after a few days of operation, even sometimes a few months. Most of the problems comes after you have the like a full weather cycle, you can say all seasons, where you have heat, cold, average weather, and so on. So for this, I don't recommend actually to use them, but I know for some applications, people use a single panels, they connect them to DC regulator to charge mobiles and so on. So for this case, you are not feeding anything directly, you are feeding it during or through a regulator. I don't say it is 100% safe, but as it is the only available source, you use it as an individually by using something in between before you feed the load. But when you have the option to throw all of this, don't continue using them. Any question? Anything? Also, Zakaria, the manufacturers, by the way, themselves don't claim that they can fix solar modules. So don't believe anyone tells you that he can fix solar modules. The manufacturers check the modules after production. Any module has a small crack, they just throw it. They don't fix it because there is nothing called fixing solar module. If there is a crack, damage, small damage, they just throw it. It goes to recycling, but not for fixation. No one can fix it because the robots arrange the cells that you saw in Michelle's presentation, not by human, even the welding points done by robots with a percentage and with the specific size. In case of a problem, they just throw it. Yeah. Any other question? Anything? Any point? Anything before we close the session of today? In Arabic, بالعربي guys, any question? أي حدا عنده سؤال بالعربي؟
شكرا على جهدك.
عفوا، أهلا وسهلا. Diodes are internal devices. No, diodes, there is a diodes inside solar modules. Most of the recent solar modules, they have internal diodes. The advantage of using these diodes is to protect the cells when you have a partial shade, because, you know, just imagine inside a solar module, you have 20 cells connected in series together. If one of them is shaded, the panel is connected to another, or the module is connected to another modules, and you still have a current flow. If it is shaded, the system will see that cell as a short circuit. So it will cause a problem in the whole panel, because 19 cells will be connected in parallel to another 20 cells from another module, and so on. So that the internal diodes protect the module, and it short circuit all cells just to protect it. So this is the point for the internal diodes. If you talk about the external diodes, that is used, but most of the recent technologies don't use this one, because this is an old, and now they have it built inside the most of the modules. But these diodes do same function. If you have a problem in one, it's just short circuit that specific module to protect it, and to protect the whole system. When you have shading or anything affects the module itself, so it's just short that module to arrange a healthy current flow without affecting the module, and the problems in the module itself doesn't affect the rest of the system. Then they share recording after. Yeah, that's okay. Yeah.
Okay.
Yeah. Yeah.
Yes.
Anything? Any question? Any last question, guys?
New chance for questions on Wednesday.
Yeah.
Also, thank you all for the participation. And yes, as written in the chat also, we will share the recordings and we will share the slides afterwards, after all the sessions are finished for the 5 modules.
Yeah.
And see you all on Wednesday. Or was it more?
Yeah, Zakaria, same thing in what I just mentioned about diodes. The reverse current is one of the points that diodes protect the module from. As mentioned, it protects the module and it protects the rest of the system. So there are a lot of parameters that the diodes protect both parts, the system and modules from, and reverse current is one of them. And reverse current is the current caused by the system. When the module has a partial shade, it will be the weakest point in the whole system, and it will have a lot of reverse current that's coming to the because this is the normal behavior and the flow for the current in general. It goes to the weakest point. So the diode protects it, so it doesn't have this reverse power. It doesn't have any reverse current coming from the rest of the system to the module, just to protect it from overheating and causing fire test. Yeah.
Okay.
I will see you on Wednesday. شكرا للجميع. Thank you very much. Please come on time on Wednesday. And if you have any questions from today, you can raise it on Wednesday. I will be available with my colleague Stan, who will be presenting on Wednesday, just in case.
يعطيك العافية مهندس نعيم. بس في بعض المهندسين عنا حابين انه يصير الدسكشن بالعربي، لانه بقول لك انه احنا بنركز اكتر بالعربي، وهم هلا يعني بدل ما يركزوا ان هم مثلا يفهموا صار يركزوا ان هم يعني يترجموا. فاذا في امكانيه في المحاضره الجايه انه يصير في زي ميكس بين العربي والانجليزي بكون افضل لهم.
للاسف العربي مش كل زملائنا اللي حيقدموا التريننج سوري اصلا عربيك. مش كل زملائنا اللي حيقدموا التريننج بيعرفوا عربي. كان ميشيل اليوم اللي قدم اول بارت وانا، ولكن باقي زملائنا ما بيحكوا عربي، فصعب انه التريننج نفسه يتقدم بالعربي. ولكن حكينا في البدايه انه اي حدا مش فاهم اي بوينت، هذا طبيعي، هاي لغه ثانيه، فعادي ما يتردد انه يسال. الغلط انه ما يسال. فاي حدا يعني عنده اشكاليه يفهم اي بوينت انذكرت بالتريننج اليوم او حتنذكر بالتريننج بالمستقبل، انا حكون موجود بكل السيشنز. ممكن يوقفوا باي وقت ويسالوا عنها، ممكن نرجع نشرحها بالعربي اكثر، يعني نتعمق فيها بالعربي مشان توصل الفكره اكثر. السؤال كمان نفسه مش ضروري انه ينسال بالانجلش. اي حدا عنده صعوبه بالانجلش ممكن يساله بالعربي، واحنا ترجمه للترينر اللي حيكون موجود معانا ونترجم الجواب كمان. يعني هي المهم انه المعلومه توصل، المهم انه الكل يستفيد، اهم من اللغه ومن اي شيء ثاني.
صحيح. خلص بتمنى من الجميع انه ما حدا يخجل انه هو يوجه السؤال بالعربي او يقول يعني يعيد. في المهندس نعيم موجود وهو ممكن يعيد لك الشغله اللي انت مش فاهمها باللغه العربيه عادي. فخذوا الامور ببساطه يا جماعه.
بالضبط، التريننج معمول لكم، يعني هذا احنا موجودين عشانكم يعني. فالفكره ما تترددوا. والزملائنا اللي موجودين عندهم خبرات طويله جدا باماكن مختلفه بالعالم، مر عليهم كثير حالات عمليه، فممكن تستفيدوا منهم كثير. فالنصيحه ما توفروا اي سؤال اي استفسار. كلهم مصدر كويس وقوي للمعلومات، وهم مستعدين وموجودين بس عشان يفيدوكم، عشان انتم تستفيدوا وتنتقل هالخبرات هاي لكل الزميلات والزملاء. فما تترددوا باي سؤال باي شيء. يعني مره ثانيه، يعني هو معمول لكم، هذا وقتكم مش وقتنا يعني. تمام. مهندس محمد او محمود.
الله يعطيك العافية نعيم، والشكر موصول لكل الزملاء اللي مشاركين من طرفك في المحاضرة. كبداية أنا بعتبرها بداية كثير موفقة ومهمة. أنا عندي بس توصية للقاء اللي جاي، إنه إذا كان ولا بد التدريب بالإنجليزي، وإحنا ما عندناش مشكلة يعني، على الأقل هو يمكن في موضوع الفهم والسماع بالنسبة للشباب الأمور مش صعبة كثير بتوقع، خاصة إنه في عندنا أوبشن موضوع تحول تعمل السكريبت تحت، يمكن الشباب بيعرفوا. لكن الريكومنديشن تبعتين يكون في أثناء التدريب المدرب على الأقل كل شوية مثلا هو يعمل زي فيدباك له، يعمل كويز صغير، يعمل أسئلة، يعني كل ما يمشي مثلا جزئية محددة هو يقف ويعمل أسئلة يتأكد من إنه الرسالة تبعته وصلت. فأنا بعتقد الأسلوب هذا ممكن بخلي الشباب مركزين أكتر، وفي نفس الوقت هو بكون عنده فيدباك، يعني إنه أنا صح، أنا ماشي أون تراك. بس يعني هاي هذه الجزئية. كمان نقطة تانية أختم بيها إذا حبيت أو بعد إذنك، إنه يكون الحكي شوية أبطأ. يعني أنت ما شاء الله عليك، أنا ما توقعتش إنه إنجليزياتك كتير، يعني الترانسميشن عندك كتير سريع. هذا بصعب المهمة مع الشباب، خاصة إنه يعني ما تاخذنيش الشباب كل الزملاء اللي ملتحقين بالدورة يعني دينيهم مش كتير فاميليار مع الإنجليزي. وكمان البداية بتكون لسه بيحتاج شوية وقت قبل ما يبدأ يتكيف مع المصطلحات والخلاف. بكل الأحوال أنا بقول اللقاء كتير مهم كان وكتير مثمر، وأنا بشجع كل الزملاء وبضم صوت لصوت نعيم إنه الحواجز يعني الحياء خلينا نقول من السؤال والتفاعل لا نرفعها جميعا. أنا زي ما أنتم شايفين والزملاء هبة كل الزملاء بنتكلم بالعربي بأريحية، مع إنه ممكن واحد يعمل خلينا نقول المداخلات بالإنجليزي، لكن عشان نقول إنه المداخلات بالعربي في أريحية فيها اللقاءات الجاية أنا كمان بتوقع حتكون الأمور بالنسبة لنا كلنا أحسن، يعني كنا تكيفنا مع بيئة التيم، إحنا يمكن متعودين على بيئة الميت، كل شيء اختلف علينا بالمعنى. فبالإجمال أنا بعتبره لقاء كان موفق جدا. وأختم إنه فقط إنه النقطة اللي أنا حكيت فيهم ريكومنديشن يكون المدرب أبطأ شوية، ويعمل نظام أسئلة كل ما يعدي جزئية كل ما يعدي جزئية صغيرة يعمل هو أسئلة عليها عشان نتأكد إنه إحنا يعني اون تراك. وفي زميل إنه بعمل هنت إنه يكون في تسجيل للمحاضرة بحيث إنه إحنا نعملها يعني نرجع لها لاحقا لو واحد فاتته جزئية، لو طلع لأي ظرف يكون في تسجيل للمحاضرة. أنا شفت يبدو إنه مريانا عملت هنت لبعض الزملاء إنه التسجيل موجود، حيصير له شير إن شاء الله. كل احترام لزميلنا يعني نعيم ومريانا والفريق كل المدرب اللي معه، كل احترام والتقدير، والله يعطيكم الف عافيه.
الله يعافيك. يعني زي ما حكيت هو التريننج حيكون مسجل وحنعمل له شير بنهايه التريننج. ويعني بضوء على نقطه مره ثانيه، الكل اللي حيقدموا التريننج كلهم جايين من خبرات عمليه، حتى التريننج نفسه والسلايدز مش شيء نظري تقليدي. هو كل الكلام اللي بتقدم ممكن شيء بنحكى اكثر من اللي مكتوب لانه نابع عن خبرات. فهي نقاط مهمة جدا لكل الزميلات والزملاء انه ياخذوا هاي الفرصة يسألوا اي شيء، لانه مبنية على خبرات عملية طويلة ومهمة، وكلنا بنتعلم من بعض. يعني كنا امبارح نتعلم واليوم نتعلم وبكره بنتعلم، فهذا طبيعي يعني في الحياة، وهي سنة الحياة. فما حدا يتردد، اللغة مش مشكلة، واحنا موجودين ان شاء الله معاكم على طول الخط لاي شيء، حاضرين ان شاء الله. Yeah, you can close.
Okay. Yeah. Thank you all, and see you on Wednesday. Yes.
Inshallah.
Inshallah.
إن شاء الله.
Thank you so much and goodbye.
Thank you.